I'm going to show you
24
how to
मिनट का
get
रिकॉर्डिंग
started
है
writing unit
कितना मिनट
tests
का?
for the HTTP request in your apps. I think it's pretty well accepted these days that writing unit tests increase the quality of your code and that their benefits are well worth the extra development time they require. The Angular team obviously feels the same way because they've built special testing tools not just for HTTP requests but for the entire framework. They've also made sure that new Angular apps created with the Angular CLI already have all of the external testing tools you need installed so that you can easily write tests right from the very beginning. I'm not going to cover all of the ins and outs of unit testing in general or even Angular unit testing, but I will show you how to get started writing very useful unit tests for your HTTP request that will
बताइए ठीक है बात सही है लेकिन पहले बेड लगाया रहता है इसीलिए
hopefully help you identify problems in your code before you get a late night phone call reporting the problem in production. There are lots of client-side testing tools to choose from, but I think the fastest way to get started unit testing your Angular apps is to use the default tools that get installed with the framework. The two most important of those are Jasmine and Karma. They aren't automatically included with the framework, but if you create an app using the Angular CLI, they'll get installed by NPM when the new app is created. Jasmine is a very popular JavaScript testing framework that includes all of the methods you need to execute some bit of code and check that the results are what you expected. Karma is a test runner. It executes the test written with Jasmine and reports the results. One nice feature it has is that it can run in the background and automatically rerun all of the tests every time the code changes. The Angular framework itself also comes with a number of utilities that facilitate testing. They generally do things that help you simulate a running Angular application so that the code you're testing executes as it should. We'll use a couple of these utilities in this module. The Angular CLI facilitates testing by providing the ng-test command that will let you build and run all of your tests from the command line. If you create your app with the Angular CLI, your package.json file will be pre-configured with an npm script named test that will start your test with the ng-test CLI command. That's just another option you have for starting the test runner. I won't be going into great detail on how to use Jasmine, but I want to at least quickly show you what I think is probably the most common structure for creating tests with it. They begin with a call to the described function. It effectively describes a suite of tests which are often referred to as specs. The first parameter passed to it is just a string you can use to describe the group of tests, and the second is a function that will contain the test. It's common to use an arrow function for that. Inside the arrow function, you can make a call to the before each function to perform any setup that should be run before each test is executed. The setup code goes inside a function passed to before each. Each of your tests are defined inside a function named it. The first parameter to it is where you pass a string describing what it is the test will do. The second parameter is another arrow function that will run your application code and test the results. You'll likely have multiple calls to it inside a given test suite since there are probably several things you'll want to test. Very similar to the before each function, there's also a function named after each, where you can put any code that you want to execute after each test in the suite. This certainly doesn't represent all of the Jasmine API, but these are the most common functions and the ones I'll use in the demos shortly. Angular comes with two classes specifically created to help you test your HTTP request. The HTTP client testing module is an Angular module that just configures a test backend for your HTTP request. You have to configure your test to import and use it, but then it just handles the request and you don't really have to think about it much again. You will have a little more interaction with the HTTP testing controller class. It creates mock HTTP requests for the requests made in your app and includes methods that let you specify the HTTP response that should be returned by the mock request. You can write tests against the mock request as well as how your application code processed the response returned by the mock request. Let's next take a high-level look at how you use these classes in your test. I mentioned earlier that Jasmine's before each function is where you should put any setup code that you want to run before each of your unit tests. Because each test needs to start fresh, this is where you should configure an Angular test environment. Another Angular test utility is the testbed class. It configures an environment for running your Angular unit test. It also implements Angular's injector interface, which means you can use it to inject the classes you need into your test. Here I'm calling the configure testing module function on it and passing it an object literal. Since I'm configuring a module, the properties on the object look a lot like the properties you normally provide to the ng module decorator on your own modules. I use an imports property to import the HTTP client testing module, which will provide the HTTP backend for my test. I also use a providers property to specify the services I need provided here. This will make sure I can get an instance of the service I want to test from the module's injector. That's the other thing you normally do inside of a for each function. Retrieve instances of the service you want to test and an instance of the HTTP testing controller I showed you earlier. Because the testbed implements Angular's injector interface, I can use the get method on it to pass it a type in order to get an instance of that type from the injector. Once I have an instance of the service I want to test and an HTTP testing controller instance, I'm ready to start writing my test. Remember that your tests are written inside an it function. This code will test that my service returns the correct book. The first thing I'll have it do is execute the application code I want to test. This will test the getBookById method on the service and pass it ID 2. That method returns an observable, so, just like in my controllers, I need to call subscribe to make sure that the request actually happens. The success callback will be passed the data from the response, and it's inside that callback that I can make some assertions about that data to make sure it's what I expect. The callback executes asynchronously, so it's only going to get called after we do some more work below to mock the request and send it a response. We use the HTTP testing controller to get the mocked request. You do that by calling a method on it and passing it search criteria so it can find the request made by your code that it needs to mock. I'm calling the expect1 method and passing it the URL /API/book/2. This tells the controller that there should have been exactly one request made with a URL matching the one here. If that is not the case, an error will be thrown and the test will fail. If a matching request is found, it will be mocked and assigned to the variable I've declared. You may then test various things about the request to make sure they match what you expect. This is a good place to check things like the HTTP verb being used, headers you expect to be passed, and other things stored on the request. You generate an HTTP response for the request by calling the flush method on it. You pass it the body of the response you want it to generate, and you can optionally pass it other things like headers and specific status codes. I don't have any of those on this request. This is the response that will then be processed by the success handler in the subscribe method above. Let's now go add some more detail to this and write some real tests for the book tracker app. In this demo, I'm going to create a new file to test the data service and show you how to write tests against HTTP requests and responses. I'll start by adding the new test file to the core folder. I'm going to be testing the data service, so I'll name the file data.service.spec.ts. As I mentioned earlier, tests are known as specs, so the name of your test file should end with spec.ts. I'll paste in the import statements I need at the top of the file. We haven't seen these first two lines so far in the course. The first one imports the Angular test bed from Angular core testing. It's one of the Angular testing utilities that helps create the proper Angular environment in which your tests can run. The next line imports the two classes I already talked about, HTTP Client Testing Module and HTTP Testing Controller, as well as a third class named Test Request. These are being imported from Angular Common HTTP Testing. It's also importing data service and book, since I'll also need them in the test. I'll use a code snippet to stub out the basic Jasmine functions I'll use. A suite of tests is defined by a function named describe. All of the actual tests will be created inside it. The string here is just a way to give a name to this suite of tests. Before I write any actual test, I'm going to declare a couple of variables to store objects I'm going to need throughout the suite. I'm testing the data service, so I'll need it just about everywhere. I'm also going to use an HTTP testing controller in each of the tests. I'm not initializing either of these variables here. I'll do that inside the before each function. Before each is the place where you should put initialization code that should run before each test. The first thing I'll do there is use the testbed class I imported to configure the Angular testing environment. I'll call the configure testing module method and pass it an object literal. As you saw me highlight on the slides, I'll use the imports property to import the HTTP client testing module, which will serve as the HTTP backend. I also need to provide the data service so I can receive an instance of it from this module's injector. Now I'm ready to assign values to the two variables I declared above. I'll get instances of them from the test bed by calling its get method and passing the type I want. I need a data service instance and an HTTP testing controller instance. Okay, what I have so far is really the basic setup you'll need to test HTTP requests regardless of what your app is designed to do. In order to actually write the test, you'll probably need some additional things that are specific to your app. The book tracker app is all about books, so I need some books I can use in my test. I'll declare an array of hard-coded books with 3 books near the top of the describe method with the other variables. This gives me some data I can return in my mock HTTP responses. Now I'm ready to write some tests. I've already got 2 tests stubbed out at the bottom of the file. Tests go inside a call to the it method, and these 2 tests are just labeled test1 and test2 for now. I'll change the first one to state that the test should get all books. I want to test the get all books method on the data service, so the first thing I'll do inside the test is call that method on the data service instance I initialized above. I showed you earlier in the course that until you subscribe to the returned observable, the request won't be made, so I'll chain on a call to subscribe. I now need to retrieve a mock of the HTTP request made by the method. I'll declare a new variable to store it. The mock request returned from the testing controller have the type test request. You generate a mock request by calling one of the methods on the HTTP testing controller. The match method will return an array of requests that match a parameter passed to the method. Expect none takes a URL as a string and expects that no requests have been made with it. An error will be thrown if it finds one. I'm going to use expect one. It also takes a URL as a parameter and expects to find that exactly one request has been made to the URL. Finding any more or less will throw an error. If it finds exactly one, then it will mock a version of the request. The request inside getAllBooks should go to /API/books. We can use the return test request to make sure it looks like the type of request our app was supposed to generate. I'll put my cursor on the test request type and press Alt F12 to view the class definition for it. The comment on the class tells us that it's a mock request that was received and is ready to be answered. It also gives us access to the actual HTTP request and methods that let you generate responses. The request property contains the underlying request, and a little further down you can see the flush and error methods that let you send a response to the calling code. Back in my code, I'm going to test that the HTTP request made by getAllBooks used the get HTTP verb. I'll use Jasmine's expect method to check the method property of the mock's underlying request. I'll chain on a call to Jasmine's toEqual method to see if the method is get. If it's not, this test will fail. The next thing I'll do is call the flush method and pass it the array of test books I declared above. That will add the books to the body of the response sent to the calling code. I could also optionally set other properties on the response like the status code and headers, but I'm just going to set the body here. I can handle the response and test how getAllBooks processed it inside the success handler passed to the subscribe method. We know that it will take an array of books as a parameter, and it should be the same array sent in the response from the server. Therefore, I can test that the length of the array is 3, since that's how many books were in my test array above. If the length of the array here is anything other than 3, the test will fail. The last thing you need to do at the end of every test is call the verify method on the testing controller. This tests that all HTTP requests have been handled and that there are none pending. If there were, then that would also cause the test to fail. Okay, this test is now ready to run. I'm going to run it using an npm script that came with the package.json file created by the Angular CLI. Inside package.json, there is a script here named test. All it does is run the Angular CLI test command ng-test. This will build the app, run all of the tests, and then it will sit and watch for changes to the code. When they're detected, the test will automatically be run again. I'll start it in the terminal with the command npm test. Once the app is built, the tests are run, and you can see the results here at the bottom. Executed 2 of 2, success. The second test is still just a stub I haven't added any code to yet. If you look closely at some of the other output above, you can see that Karma is attempting to launch a browser. In addition to reporting the test results here in the console, it will also post them to a web page in a browser window. I'll switch over to it just so you can see what it looks like. It's currently reporting that I have 2 specs and 0 failures. Below that, you can see the labels I used to describe the suite and the individual test. This page will also automatically refresh as the tests are rerun when code changes are detected. I'll show you the results in the console from here on just because it's a little quicker. Back in the editor, I'll make the terminal a little smaller so I can make some changes but still keep an eye on the test results in it. Just so you can see what it looks like when a test fails, I'll go back to the code and change the expected HTTP verb from get to post. The file is auto-saved, which triggers the app to be rebuilt and the test rerun. The failure appears in the console. I'll scroll up just a bit and you can see the message expected get to equal post. To fix it, I'll just change the post back to get. Everything reruns and now both tests are passing again.
पीएफ तो ऐसे अंदर जाता नहीं है, फिर नीचे हो जाएगा।
Another test of the data service and show you how to test HTTP errors. I'm going to add another test to the same spec file I worked on in the last demo. But before I do that, I'm going to open the data service and refresh your memory on how I'm handling errors in it. Remember that in the getAllBooks method, I'm using the catchError operator from RxJS to process any HTTP errors that come back from the server. If I get an error, the handleHTTPError function is called. It's defined right below. It takes the HTTP error response object that was generated and converts it into a book tracker error object with the error number property set to 100 and the friendly message property set to an error occurred retrieving data. It then wraps the object in an observable and returns it. So I think what I want to test in the spec file is that when an error occurs, it does properly convert it to a book tracker error instance. I'll change the label on the second test to should return a book tracker error. It's going to call the same application code as the previous test, getAllBooks. I can mock the request with the same line of code I used before, so I'll just copy and paste it into this test. I'm really focused on how an error in the response gets processed, so I'm not going to test anything on the request right here. You can simulate a network error by calling the error method on the test request object. However, to test normal HTTP errors, I think it's easier to use the same flush method I showed you in the last demo. The first parameter to flush is what should be sent in the body of the response. I don't really care about that here, so I'll just pass the string error. The second parameter is an object literal that lets you set some specific properties on the response. I'll mock a server error here by sending back a status code of 500 and status text set to server error. That should trigger the error handling code I showed you a moment ago in the data service. I need to test how all of this is handled inside the subscribe method. The first parameter is the success handler. I'm specifically trying to generate an error, so the success handler should never get called. If it does, I'll have it call Jasmine's fail method fail. The second parameter to subscribe is the error handler. It should receive a book tracker error as a parameter. I haven't imported that type into this file yet, so I'll use the little quick fix light bulb to do that. Inside the body of the arrow function, I'm going to use the Jasmine expect function to test that the 500 server error got converted to a book tracker error object with the error number property set to 100. I'll also test that the friendly message property is correctly set to an error occurred retrieving data. The last thing I need to add to this test is a call to the verify method on the HTTP testing controller. I mentioned in the last demo that this should really be the last thing you do in all of your HTTP tests. Because of that, I'm going to take advantage of a Jasmine method that will run after each of my tests. It's very much like the before each method I showed you in the last demo, but this one is cleverly named after each. I'll cut this line of code and then go back up toward the top of the file and write the new method. I'll add it just after before each. Their structure is identical. Inside the arrow function passed to the method, I'll paste the line of code that calls verify. I now no longer need to call it at the end of the first test I wrote, so I'll go remove that line. Okay, I'm now ready to check the results of this second test. Remember that the tests are automatically running as I update the code. I'll open the console again and we can see that 2 of 2 tests are successful. I'll leave this open and quickly change the test code to expect the error number property to be 200 instead of 100. The test quickly rerun and I get a failure message in the console. I'll scroll up just a little and you can see the message expected 100 to equal 200. I'll change the code back to 100 and the test rerun and everything is passing again. Writing unit tests is high-quality code that you can refactor with confidence. Thankfully, the Angular team agrees and they built testability into the framework from the ground up. The ability to test those all-important HTTP requests. With the help of the HTTP client testing module, the HTTP testing controller gives you several ways to test how your code creates and processes HTTP requests and responses. I hope you'll take advantage of them and avoid those late-night phone calls that require you to debug a problem in production. Okay, that wraps up that you've enjoyed watching it. And most importantly, I hope you've learned a lot along the way. Thanks for watching.